the exercises are in the book. I sent you the book in the email, yeah? PDF.
You did?
Well, you have the book.
I can't find that book.
It's on the internet.
I wasted like 20 minutes of my life trying to find it. I just couldn't find it.
It's funny, you know, like when I send people the book, you know what I do? Okay, I look in my email sent list, okay? I look at Kavan's email. I actually, seriously, I just go to his email that I sent and I forward that to other people.
Oh,
That's how you guys got the book, okay? So there is no way he did not get sent.
Wait,
I'm
was it
reminded
the
of that
same
fact
one
every
as
time I
Heron's
send
Formula?
someone.
I know you. I got sent it.
Just search
Oh,
it
it was under the name of Heron's Formula.
Bro.
Wait, no, it's not. It's not.
It's
with me
probably
before.
under the name of G.O. Book.
I tried that.
G.O. Book or book.
PDF.
PDF.
Search his email. They slapped this in Spanish.
Yeah, I did that as well. I went through all of his emails. I couldn't find it.
Alright, so
Yeah, I'll do it.
3.1.
Oh,
Oh, come on, man. This is like. I see.
Oh no.
Well, I guess you can put half a sandwich in there still. Alright, so what? Okay, I'm not gonna do the exercise then. I'll go through the first one and I'll kind of. I'll make some like observations about the other ones, and then we can come back to it when maybe you tried two. Okay, question two. So I'll definitely.
I tried it.
So the first question was the perimeter of the Varignon parallelogram equals the sum of the diagonals of the original quadrangle. Does that make sense? So you have a quadrangle, yeah?
You know it's Krispy Kreme?
Yeah. This is 3.1.1. So you remember how you take the midpoints? Remember this? And you get a parallelogram? You remember that?
Yeah.
That's the Varignon whatever parallelogram, yeah? And the question asks you, the perimeter of that parallelogram equals the sum of the diagonals of the original quadrangle. Remember that? Okay, so this is the diagonals, yeah?
I swear we could just do the parallel thing.
Yeah, you can.
Yeah,
It's literally just it.
Yeah?
Cause
Yeah, so these are
That's
the
fine.
midpoints, right? Yeah?
yeah.
So it's parallel to this, yeah?
Wait, if you go from the center, right? The center two green lines is equal to those two blue lines. You know this, like this
Uh-huh.
is equal to that.
It's easy if
Yeah,
you just
I mean,
do one
it's-
diagonal and then
yeah,
two parallel.
Yeah, true.
So like the perimeter is the sum of this side plus this side plus this side plus this, right? But this side, right, is half the length of this side, yeah?
Yeah.
Because that triangle is similar.
What are we doing?
Yeah. Alright.
The perimeter of the parallelogram is equal to the sum of the diagonals.
So we're showing the perimeter of this, right? The parallelogram, okay, is equal to the sum of the lengths of the green lines.
Oh,
Yeah? Okay.
thank you.
Very
cool.
Alright. So in this triangle, yeah, this is parallel to that, yeah? These are the midpoints, okay? Yeah?
Well, firstly, there's two things that are literally parallel.
So
You
that's
just get rid of the
half
middle.
the length of that, yeah? And the other one's actually half the length of that too, yeah? So if you add them together, you get the diagonal.
Yeah. And you do the same for the others.
See that?
Whoa.
So then you do the same for the others, you get that diagonal. That's the first exercise, yeah?
They're nuts.
Okay, I mean, some of the other exercises, I mean, you still have to try them. So the second one says the sum. Okay, that's not over, by the way, right?
What?
That's not the end of the exercise.
Oh, it isn't?
So what is the end of the...
Oh, that's the
Remember the only thing that I said to beware of in this? Quadrangle.
Oh, no! No,
Yeah.
no,
Yeah,
no,
so,
no, no.
so this is you're forgetting the only thing I told you not to forget, right?
Oh,
This is
no.
not the only type of quadrangle that there is, okay?
Oh, no.
Yeah?
Oh,
There's two other types of quadrangles.
Okay, we got this.
Yeah.
Let me do this right now. Wait, can we do this right now?
Oh, well, I can't stop you, but like, yeah. Okay, so the other exercises are, so the sum of the squares of the sides of any quadrangle, so the sum of the squares of the outside length, yeah,
What the hell?
is equal to the sum of the squares of the diagonals
That doesn't even make a parallelogram.
plus 4 times the square of the segment joining the midpoints of the diagonals. Okay.
Why you say that funny?
What the hell, Leo?
So
You drew it wrong.
the square of the 4 squares on the outside, right, is equal to the square of the diagonals plus 4 times the square of So if you take the midpoint of this diagonal and the midpoint here and join them, that length squared times 4.
This doesn't even have diagonals.
That's so random.
Yeah.
What is the diagonal?
It's pretty random. I mean, you have to think about it. And the third question says, for a parallelogram, the sum of the squares of the sides
Oh, yeah,
equals the
that's
sum of the squares of the diagonals. Okay?
Yeah.
So actually, can you see that
You can do
the
it
second
by-
question implies the third question?
Yeah, which is
Okay.
why I did 3.
Because the midpoints of the diagonals of the parallelogram are actually in the same spot, right? They bisect each other, so there's a 0 length. Yeah? So then for a parallelogram, the sum of the squares of the outside is just the sum of the squares of the diagonals. So if you assume that 2 is true, right, then it's true for a parallelogram. Actually, maybe what's not so obvious, like I haven't tried this, but it looks like 3 actually implies 2 as well. Okay?
Oh, it does.
Well, you might have to check it.
Price up.
And it looks like 2 and 3 somehow imply 4. Okay?
Yeah, they also.
So they're all very much related. So sometimes you don't have to actually solve a question to sort of make huge progress. You know, like if you're solving for 4 variables, right? You don't have to find each one to make progress. Yeah.
Yeah.
You just have to relate one to the other 3. That's when you lose a variable. Yeah. Makes sense. Yeah.
Michael,
Yeah.
in this case, what's a diagonal?
This is joining.
It's
the
AC.
opposite.
Yeah.
It's joining one to the opposite. Come on, can you think?
What is this
Yeah,
and
that
this?
and that. Yeah. Oh, I know.
Yeah. I mean, in some of these questions, like
Why?
See, look, this is half
Why?
that. This equals that plus that, and this equals half
Yeah,
that.
because
So
this is
what-
half.